Good morning, everyone. My name is Aleksandra Salamurovic. I am academic coordinator of the Seafield project, and I would like to welcome you to the Southeast European Studies online platform, a lecture series in which various academic institutions dealing with the region or originating from the region present and discuss their ongoing research projects. And today we begin our fresh round of the CSOP talks on the paradigm of digital humanities and its role in the development of the area studies. Our invited speakers come mostly from our partner institutions, and they will present their research on applying tools, methods, and techniques to analyze various data, covering history, linguistics, anthropology, and language education. And I'm particularly delighted that we are kicking off the new season of the CSOP talks with two linguistic topics. So let me introduce our first speaker, Benedikt Perak. Benedikt Perak is assistant professor at the Faculty of Humanities and Social Sciences at the University of Rijeka. He holds a PhD in linguistics and teaches courses, of course, in linguistics, digital humanities, and data science. His core research revolves around cognitive linguistics, conceptual metaphor theory, application of digital humanities methods, natural language processing, and artificial intelligence in social interaction. He leads the Center for Language Research in Rijeka Cultural Complexity Lab. I found this title very compelling, and a laboratory within the University Center for Artificial Intelligence and Cyber Security. He has been involved in several significant research projects, such as one that examines the linguistic expression of emotions, political rituals and cultural memory, and formal reasoning and semantics, to name just a few. And today, Benedikt will be talking about AI assistance in tourism, enhancing cultural enrichment experiences. So Benedikt, the Zoom is yours. You can start.
Maybe I can start sharing the screen. Thank you for this kind introduction, Aleksandra. It's wonderful to be here to present some stuff that's quite intriguing, I would say, for the community, and to be able to interact with my colleagues. So I'll start with this theme that was settled back then, few, I would say, weeks or months ago. At that time, we were in the process of thinking what can we do in terms of cultural complexity and research that somehow surpasses the purely linguistic form of analysis that was more or less pertaining to what we have been doing in the past, you know, all this discourse analysis, metaphor resolution, etc. And let me say why, because last year, I'm certain that you know, there was this GPT revolution, and that kind of hit us like a meteor. Some people understand that the meteor has fallen, the impact is already here. Some are still asking themselves, what is this hot wind in the air? But in fact, the new type of paradigm in terms of discourse tasks is already here. And that's where we kind of thought, okay, we need to see more than just the discourse or analysis, and more than just some kind of setting that pertains to linguistics itself. Let's move on to something that has the discourse in itself, but engages with the cultural setting more than you know, just an artifact that has some kind of value for the museum or some kind of representation etc., etc. So the tourism has this kind of domain interest, which gathers the language, the communication structures that we, use to, see what's all around us. And the second thing is that we have in our community here in Rijeka quite large cultural enterprise that could be stepped up into the tourism sector. So not on tourism for the tourism itself, but to have the cultural engagement for the tourists and using AI to do so. Of course, this picture paints quite an AI type of a tourism frame, but nevertheless, I think that we can get into there. So I will just point to where this large language models as a communication structure fit in and give you a few examples of what I mean. So, but AI as what that thing is, we could say that's ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings. So it has this mimicry inside. And what this mimicry is all about, I think this
Artificial
lady
intelligence,
can show us.
AI, is the ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings.
Yes, so it gives some kind of illusion of intelligence. It is like a pattern that can, replace certain features of representation of intelligent interaction. So what are these systems all about? In any AI, we have lots of components, but these are the sensor, the robotics, actuators, computer vision, of course, the machine learning as a prerequisite for any kind of computer system to learn on the data to perform this task that have this analysis and analytics and prediction type of methodology and paradigm. I'll be focusing on this natural language processing ability of this AI. So it's an ability to understand and interpret human language in structures that we all know and are dear to our heart, like words, phrases, etc. But also some complicated stuff like disambiguation of words, metaphors, etc. So we are living now in this industrial revolution, so to say, fourth, and we see the fifth in some future times, not so very far away, where nowadays we have all this data that we can analyze. We can have all these various type of interactions to various interfaces, and this interaction actually brings about even more data. So what's the next level out there? It's the so to say responsive 21st or personalized type of artificial intelligence. So what that means, we are now producing the basic material that will help the future machine learning, artificial intelligence, data science, bring about your personal type of artificial intelligence systems that could connect you with the world. So assisting is what this all about. I would say this AI is not something that will, we can talk about that later, replace some task, yes, but it will be a tool for assisting in various ways. Ray Kurzweil mentions that by 2029, the computers will have the capacity to have emotional responses. So by 2027, some researchers say it will be indistinguishable to communicate with these systems like we have here, some kind of communication, etc. So All these advantages are due to the development of deep learning, machine learning techniques, and especially this transformer type of representation, where you take large sums of texts or corpora and then turn that into vectors, which feed basically the representation of words as tokens. That means any token in the model is represented as a kind of various possibilities of this token interacting with any other token in a vector space. So basically what these machines are creating is semantic space for words and creating a vector representation for any number of contexts this particular word or token can be used. So amazing stuff that can do various things. So data as an input can be text, images, speech, structured data. These things are turned into the numbers. That means they created this vector space. And with these foundation models or these large language models, you can do any number of tasks like question answering, sentiment analysis, information extraction, capturing image, object recognition, and of course this instruction following. So this is previously unheard of, because every machine learning model before these transformers had their own task. So you should learn that the model to perform sentiment analysis only, or lexical disambiguation only, etc., etc. Now with these new type of language models, which are getting bigger and bigger, you can actually have these emergent abilities where you just train on one task, that is predict the next word. That's basically the only task that they have, and they at certain level of complexity within this network start to have these emergent abilities of creating algorithmics, transliteration, kind of words and creating words and in context, etc., etc. So with a single model, you can use that for different tasks. You can fine-tune model with minimal training data to suit your needs, and the performance is continuously still growing with more data and this strength of network. And what are the common tasks that you can perform is text classification, question answering, document summarization, or text generation. We all know this text generation with this ChatGPT and the problem in academia that all the students are performing so quite well on this essay task. But that's quite trivial kind of use of these large models. And in tourism, you can see that the AI will have different type of intrusions, so to speak. First, there will be lots of these chatbots and virtual assistants ongoing. So travel agencies, the tourism websites will employ these AI-powered chatbots to provide instant responses to customer queries. Of course, they will be personalized. So due to user preferences, past travel history, behavior, they will offer this personalized travel recommendations. And the benefit of these large language models, if they are trained on multiple languages, is that they have language translation capabilities. So you can ask in German, and the training data is in Croatian. Doesn't really matter to the system, because everything is stored anyway in the vector space. So this translation can use lots of data from other languages, translate that in any other target language, which is, I guess, Michael's part of the talk also. So predictive analysis is what's actually quite interesting, because you can predict what would be the optimal range of prices for this or that. You can combine that with personalized recommendation, etc. Etc. So I'm not going to go into detail, but the last one is the data insights. So the AI can help tourism to gain better and deeper insights into customer preferences. So and to get the feedback and feed that into next iteration of the offering. So what's that has to do with the culture? Well, cultural insights of AI can provide tourists with deeper cultural insights. So by analyzing historical data, offering context to cultural artifacts, and suggesting immersive experiences. So any use of these tools, from just plain chatbots that can replace any number of personal assistants at the museum or here or there. Sometimes you don't have these people, just roaming about these institutions. So if you put many or just one assistant, AI assistant at the tourism, at the museum, you will perhaps better understand the whole exhibition, etc. So we have been there are a number of already tools out there. So on ChatGPT, you have, for instance, Expedia tool that can provide you with lots of, just quite nicely done interface for searching your, for instance, I said, I want to go to in Ljubljana on Thursday, and here is some excellent recommendation with all these ratings, and there's a booking link where you can actually go and search and book. So how can we actually combine that with cultural settings? We have been engaging with Humane Flux project that has something around 200 markers for Rijeka created in various languages, and we wanted to actually refine this app to use more of the data itself, because they've created just a keyword structure search. So if you go and search for opera, maybe you will not find anything because there is no keyword opera. So that's a shame. And I've tried to create a marker with keyword graph that could harvest potential similarities of different markers. So you can see that, for instance, Bazovica, some association, has this kind of structure where you see that it's an association, it has to do with socialism, it has to do with minority. So using this kind of tools, you can see that La Voce del Popolo is kind of close connected node, and the similar kind of stuff, but on a larger and more refined version, you could do that with if you would search for triples inside text. So if you search for I want you to, and who would do that? We first wanted our historians to do the tagging, to tag all the entities, persons inside text, and to see what these entities have in some kind of relation with each another. But that took some time. And if you set a prompt for GPT-3, please find all entities that have to do with history, politics, economy, architecture, find the relationships, and then create a JSON file that has this kind of structure. You get 3,000. That's number of relations. That means we got something around 120,000 relations. And these are unique entities that actually was extracted from these 120 or 150 texts. So you can see how neatly everything gets organized, and you can get various types of relations that finally in a graph look something like that. So it's quite amazing conceptual network structure that is expressed as triples, so subject, relation to object. And then this kind of allows you to extract various data from various sources and present this in a fashion that could be also, if this is zipping your information in a triple, you can unzip that in the similar kind of fashion where you use again this AI to unzip the answer to you. So it's quite amazing. So this is one approach. The second approach, not to just extract the information and then store that as a database, but to use the LLM in itself. But the problem is that these large language models hardly use your own data that you would like to kind of present. So there is work around that also. So nowadays, also in various type of products and various type of pipelines, but basically you have this external knowledge. So whatever that means, your news, Wikidata, proprietary databases, and then you actually set this into LLM, you convert this knowledge into vector space, and then have some kind of policy how you want to interact, and then store your knowledge into working memory and use the LLM to actually engage with the question that goes in to represent this as a kind of prompt, and then to have the engagement with the LLM with your working memory. That makes lots of sense. There is LangChain nowadays, quite prominent library in Python that you can use. And what they do is you take documents, you split them into this window frame, create the embeddings, and this is that pipeline. So you have a question and the similarity search searches for your answer in your vector store, your database. You get relevant chunks, you send that to LLM, and you get the answer. So, for instance, if you feed what's this article about, and then you get what is this article about, or any kind of stuff. So we created first some kind of assistant for our university where you can, how can I help you? How can I get to the Filozofski fakultet? Can I, get admission to Filozofski? No, you cannot, or you can. That's whatever there is. Or, for instance, if you want to visit Opatia, that's the similar kind of Expedia. But the next one that I would like to kind of wrap up a little bit is our A1 and Matetic, that has to do with Matetic Rongov institution. And you can see how actually we've done this whole data structure creation inside the so-called GPTs infrastructure, where we have put several resources about even Matetic Rongov, and now you can talk about Matetic in English or in German or in any language. So you can see that it responds in Matetic Rongov, prominent composer, ethnomusicologist, educator, known for his significant contributions, especially known for his field work, etc., etc. So we are starting to kind of use these options to create a personalized communication assistants for cultural institutions. And the benefits of the chatbots is that, of course, they are personalized. As I've explained, they are available, 24 hours a day if you put them on server. They have this fast responses, which is actually, sometimes doubtful, but okay. And of course, they can handle large number of inquiries, so they are efficient. You can use this data, you can collect this data to get more insights into what the guests are interacting. You can, provide valuable insights. And of course, innovation is quite interesting because, in any kind of tourist setting, whether it's hoteling or something else, you can stand out nowadays by having these kind of tools that can help to get your interaction on next level, I would say. So yeah, this is my pitch, and thank you. We can maybe discuss more in the discussion part.
Okay, so we are very good in time. And we can now move forward with the second talk. The second talk features two presenters, so let me introduce them. Björn Hansen is professor and chair of Slavonic linguistics at the University Regensburg. His research focuses on structures of Polish, Serbian, Bosnian, Croatian, Russian, and Czech. And he also has a general interest in aerial typology. He has published widely on modality, grammaticalization, clitics, and language change. And his recent research focuses on Slavonic German bilingualism, language indefiniteness, and the language of corruption. And Björn is a member of the steering board of the Seafield project since 2022. He will be presenting together with Michael Wastl, who obtained his MA a few months ago with a topic on control change and machine translation analysis of German-Croatian translation equivalents on the basis of corpus-based data. Michael is working as a research assistant at the Institute for Slavic Studies at the University of Regensburg since October this year, and his main research interests involve corpus studies, complement control, machine translation, and contrastive linguistics. Björn and Michael will talk about how the recent advances in neural machine translation and the rise of ChatGPT affect linguistic work. So please, the Zoom is yours.
Okay, thank you. Okay, we'll share the slides. Okay. Yeah, thank you very much for the opportunity to present some. I will present only some general ideas about the perspectives and also the opportunities these new recent developments offer for linguistic research. But before I start, I have to say a word about the ethnonyms. Here said that in German universities, the language is still called Serbo-Croatian or BCS. This is not the case anymore in Regensburg because we recently opened the Croaticum and Lidia Cvikic is going to teach exclusively Croatian, and we have split the language courses and they are not any longer called BCS. Okay, the topic is AI and machine translation challenges and opportunities for linguistics. Okay, next slide. Okay, I will start with some general ideas and observations in the field of multilingual lexicography, what has happened during the last years. When I was a student, we used these the traditional dictionaries, German, Croatian, German dictionary, for example. This one is what I used when I was a student, when I learned Croatian and Serbian. Later on, an online dictionary appeared called Crodict, which is based on 300,000 translated texts. And this is still one of the quite useful and good dictionaries for German and Croatian translations. Next slide. Since the last 2 or 3 years, I personally switched from Crodict to Glosby. Glosby is, I think it's a Polish-based company which offers dictionaries for more, as they claim, more than 6,000 languages. And they are built on, I can't read this huge figure there, the translations. And they also include, this is the novelty in comparison to Crodict, they also include machine translations. Here I have typed in how the possible translations of the Croatian word ploča, and here you can see at the right-hand side some improved usages of improved translations. And you can see it sometimes translated as Frontplatte or as Tafel, Bedienfelder, Schilder, Glasplatten, and so on. There are several possible translational equivalents, and you immediately see the advantage in comparison to the old school dictionary book, that you see that there are nearly always several translational equivalents for one and the same lexeme in one word to the other. I also use it for Albanian. I think, as far as I see, it is currently probably the best German Albanian dictionary. We are about to check how ChatGPT, I will also get into this, is a good translator. The colleague of ours, Roman Fisun, who has also started learning Albanian as I did, he had some doubts about the quality of the translational equivalence of Albanian, but still ChatGPT can translate also into these smaller or not so well resourced language like Albanian. But generally, I would recommend, and the advantage of Glosby is that you can also translate from Croatian to Albanian, from Finnish to Italian, and so on. You can choose any language, and it's quite handy to have. And this, of course, changes our language courses. How do we teach translation, and how because the students do not use the traditional dictionaries anymore. Okay, next slide. Here you can see how it looks like. It's again from Glosby. The left-hand side, you can choose the language, as I said, and here are examples of a translation based on machine translation. These are not the other ones, and also Crodict and DeepL also developed on the basis. As a training corpus, they use translational proved translations. And of course, also Google Translate hasn't made immense progress, but this will be the topic of Michael's presentation. He will show that what are the problems with machine translation, and we will even go a little bit further. I would claim that these machine translations can give, we can use these machine translation to generate hypotheses for linguistic research, and the other way around. That meaning we do not want only to check how these tools translate, but also these translations can give insight into language structures. And this is, as I said, Michael's part. Yeah, okay, next slide. For our linguistic seminars, linguistic courses, of course, it is a challenge that, and also for the teaching of translation, that the students have access to ChatGPT. And here I have the translation of a Croatian text on the Bašćanska ploča. And yeah, I would say the German text is fine. It's absolute. It's great. There are no major problems. And the challenges for our language lectures are, how do we teach foreign languages in future, and how do we teach translations? And do we still need these dictionaries? I mean, in all these institutions, also in Croatia, we still have these bilingual dictionaries, monolingual dictionaries. We have the Hrvatski jezični portal, and so do we still need this? This is a question. And I think we should go in the direction, as is the common practice among translators already now, that the translator becomes a post editor. He does not translate the text himself or herself, but he uses a machine translation, either ChatGPT or Google Translate, and then he edits the text. This is much more effective and much quicker than translating the whole text from scratch, I think. And this is what we have to also to teach to the students, how to use these tools. I think it would be absolutely wrong to ban these machine translation from language classes. I think we have to include it and to work with students and to show them where the problems are and where the mistakes are. Okay, next slide, Michael. And of course, in our linguistic courses, we have to acknowledge the fact that ChatGPT is also a reference tool for linguistic knowledge. I asked ChatGPT, kako se može odrediti lingvistički termin enklitika or zanaglasnica. I think both terms are in use in Croatian grammar, although zanaglasnica is more frequently used in enklitika, more Serbian linguistics. And you could see here a definition. Enklitika je lingvistički termin, okay, koji se odnosi na vrstu afiksa. This is not quite correct. Koji se pridružuje drugoj reči. This is correct. Funkciju niše. This is probably not Croatian. It looks a little bit more like Serbian. Kao da je njen deo, not dio, ali je obično ne možete vidjeti kako samostalnu reč, and so on and so forth. You can see something is correct, but there are some mistakes, and it looks a little bit. This was also the observation of a colleague of ours, Roman. He said that a student who is not very well familiar with the topic might write something similar. This is very human-like. Also, in machine translation, you call it hallucinations. They do not call it mistakes, because there are some non-correct elements in this definition. Okay, this is just. I will not go through the whole of the answer, but there are some correct observations and some hallucinations in this text. Okay, next slide. And I also checked it for English and give a description of the linguistic category of clitics in 50 words for advanced students of linguistics, because you can also ask ChatGPT how he is supposed to answer. Clitics are linguistic elements that function as a bridge between words and phrases. It's not too bad, often attaching to other words, but lacking full independence. That's correct. They exhibit traits of both affixes and independent words, playing a crucial role in syntax, morphology, phonology. Clitics are prevalent in various languages, shaping sentence structure and convey grammatical information compactly. And they are intricate topic in linguistics. This is, I think, this type of text is easily recognizable as being generated by ChatGPT, especially the final phrase. But it's not too bad, but it's rather diffuse knowledge. And what I find really interesting is that this reminds a little bit of how students of the first semester or second semester might answer this question. This is very much human-like, also these types of hallucinations. Also in the, I learned that the computer linguists at the University of Düsseldorf, they use this was their idea. This was not. They used ChatGPT as an informant and also to find grammars, for example. And I also tried this out. Find the grammatical error in the following Croatian sentence. Dao mu sam novu knjigu. Of course, there's something wrong with the redosled, with the word order of the clitics. And the answer is the grammatical error in the given Croatian sentence is the word order. Fine. The correct word order should be, that's correct. But the explanation why this is correct, this is incorrect, is a hallucination. The correct word order place the subject down some is no way. It's the predicate before the object and so on. This shows that ChatGPT has the intuitive knowledge of the correct structure of Croatian, but not the the linguistic meta knowledge. Okay, next slide. Yeah, this is what I already said. ChatGPT generates text which may contain hallucinations, and they are, in this sense, they are pretty much human-like, and because ChatGPT, these Croatian texts, there were some grammatical errors, and this is what I think this would be also research agenda, which types of hallucinations and grammatical errors are found in these machine translations. We know that reference tracking is always a problem, politeness is a problem, and probably also evaluative language, sentimental analysis would be one point. And Michael will show you some problems with non-overt zero elements, and they are usually highly problematic for machine translation. But what I would argue is that we could use ChatGPT not only for in the direction that ChatGPT can generate new, not only that the linguist can analyze the potential of ChatGPT and the problems, but also the other way around, that ChatGPT can help us to find out new structures in the language which we haven't discovered before, meaning going in the other direction, meaning ChatGPT could be some sort of informant for linguistic research. This would be my hypothesis. And with that, I give the floor now to Michael, who will show in a more a detailed study on machine translation based not on ChatGPT. This would also be very interesting, but on Google Translate and how we can work with Google Translate to find out about certain structures in German and in Croatian. Okay, Michael.
Thank you for this introduction. As we all know, machine translation has been based on artificial neural networks for a number of years now, and nowadays delivers surprisingly good translations. Although this is the case, there are still situations in which these programs have problems translating certain corrections correctly. And I'm very glad that I have the possibility to present the study here, because it's an ongoing project for me, and I look forward to feedback and suggestions. So here I would like to present a study that deals with certain unrealized subjects in infinitive complement clauses in German. In these special constructions, there is often a control shift in German, which means that the null subject, we call it pro, refers to a different constituent in a matrix clause than it would be expected from the matrix verb. But we will see exactly what this looks like later on. These constructions are then translated into Croatian with Google Translate. DeepL doesn't support Croatian, unfortunately. And we can see if this is translated correctly. Okay. Let me first show you here the structure of this presentation. I will first give a brief overview of control and control shift in German. Then I will describe the research questions, and in the next section I will describe the methodology I used for the study, and then we will look at some examples of what happens when these constructions are translated. And finally, statistical or quantitative analysis will be made if this is possible with the available data. And of course, I will give a brief conclusion. Okay, so the literature on complement control in German is quite extensive and dates back to the 1950s. But the theory used for my work is primarily based on the papers by Köpke and Panther. They have also dealt specifically with the control shift in German since the 1990s. So control shift in complement constructions depends on a number of factors. So firstly, certain triggers are needed in the complement clause to trigger a control shift. Köpke and Panther have proposed an adjunctivity scale for this. We can see it on the slide. As their hypothesis is that the weaker the degree of adjunctivity of pro, the more likely it is that control shift will take place or can take place. But this is not the only factor. I will mention the other ones later on. Okay, I will not look at the first two complement types here, so A and B, in more detail, as they have a very high degree of adjunctivity and are therefore not really of interest to me. But the other types, so C till E, can very well trigger control shift. And infinitive complement, bekommen kriegen, for example, is in the middle of the scale. Then we have the infinitive complement with dürfen, and then the passive complement is the lowest. So we will now look at these using some examples from Köpke and Panther, which are of course made up sentences. But I will later show the whole thing using my own examples from the corpus because I wanted to use authentic examples. So first let's look at the infinitive complement with bekommen kriegen. So here I have the example sentence, Paul bittet Egon für den Maskenball eine Einladung zu bekommen. I marked the subject and the object in the marked clause and pro in the complement clause. Bekommen kriegen are not explicit action verbs and therefore have a low degree of adjunctivity. And here pro plays more of a benefiting role. So in this example, object control, so bitten would be a typical object control verb. If you have a sentence like, Paul bittet Egon auf den Maskenball zu gehen. But in this case, through the trigger bekommen, object control changes to subject control. It would be less likely to say that bekommen kriegen experiences an actional meaning in the sense of etwas besorgen. Okay. The next complement type, infinitive complements with dürfen. Again, I have an example sentence. Jürgen verspricht Hardy ins Kino gehen zu dürfen. We have an even lower degree of adjunctivity here. And this time, subject control, versprechen would be a typical subject control verb, changes to object control through the trigger zu dürfen. And the last complement type, passive infinitive complements. I have again an example. And following Köpke and Panther, the agent function of pro is least likely here. So again, subject control changes to object control. On the next slide, we can see the different subject and object control verbs in the matrix sentence that in general allow a control shift under certain circumstances. So there are not only bitten and versprechen, but some more. That being said, I only used bitten and versprechen for my study. The reason for this is that there are, as I already said, other factors for the control interpretation of pro, which also result from the combination of the matrix verb and the complement type. These are firstly beneficients. So who is the beneficiary? of the result of the action, then the manipulability of pro, that means the pressure exerted on pro by certain matrix verbs, and of course compatibility. So whether a matrix verb and a complement type can occur together at all. The factor beneficence in relation to pro increases with a lower degree of adjunctivity. It becomes clear when we're comparing the complement types we common kriegen and dürfen. For the former, an adjunctive reading is possible, as we have seen in the previous example with bekommen. For dürfen, it's not. The manipulability of pro, on the other hand, does not depend on the complement type, but on the matrix verb. So the authors see it as confirmed that verbs with particularly strong manipulation or verbs with weak manipulation tend to counteract control shift, even if they are in a construction with a complement type that favors this. So the matrix verbs bitten and versprechen are in the middle range in this respect, and Köpke and Panther also note that they behave most flexible in terms of compatibility. So for this reason, I selected them as examples for my study. So here are the research questions. The first and very simple question here would be how and whether control shift constructions are correctly realized when translated into creation. So in other words, how does the program deal with this construction? And the next question would be, are there major differences between the individual complement types? So it would be interesting to know whether certain types are better understood by the program than others. And the last question came, so to speak, during my first review of the corpus results. And here I realized that I also found many sentences that differed structurally in certain characteristics from the constructions I was actually looking for. And here the question is whether there are certain characteristics in the sentence that favor or counteract a correct translation. Okay. Here I would like to briefly present the methodology I used for the study. The first step was to create a quantitative database with the German corpus 10-10-20, which I used in Sketch Engine. And here we can see an example of a CQL I used here on the slide. It's for the matrix verb bitten and the complement type dürfen. So the CQLs for the other constructions looked slightly different, of course. And here I must say that this CQL also produces a large number of hits which deviated from the constructions I was originally looking for. So, for example, matrix clause without an object or a subject, or passive constructions as matrix in a matrix sentence. And these often made up a large proportion of the results. That's why I used them for the later modifications to see how this constructions affect the translation. And firstly, I have to mention that there are strong differences between the individual complement types in terms of frequency. The bitten plus dürfen construction shows the highest frequency in the corpus with 4,537 hits. But it must be emphasized again that a large proportion of these results did not realize the object in a matrix sentence. Of the example sentences that have both arguments in the matrix sentence, the first 6 results were used here as the basis for the analysis. But there were many more, so it was kind of a randomized selection. But for example, for the complement type versprechen plus dürfen, the number of usable results was only 19. So large differences. So in the first step, these overall 152 sentences were then translated into Croatian with Google Translate in order to see to what extent the control shift is realized, and whether there are differences between the respective constructions and complement types. It is important to mention at this point that in most cases, I only assess the translations in terms of the translation of the control shift. So the general quality of the translations should be disregarded, largely. And afterwards, these deviations I already mentioned, I found the corpus were taken and used as modifications to see whether the translation result changes here. And in the final step, all results were then analyzed in a quantitative manner as far as it was possible to see if there are any patterns. So now let's look at some of the examples from the corpus and their translations. I just want to show you some examples for every construction type here. The first example is, Sie haben uns darum gebeten, hier bleiben zu dürfen. It's realized in Croatian with a dark complement, Samoli su nas da ostanemo ovdje. And we can see that this sentence is not translated correctly in terms of control. We have the verb ostati in the complement clause in the first person plural, which refers clearly to the object in the matrix clause and not on the subject as it would be correct here. So the next example shows a correct translation on the other hand. And we can see that we don't have a dark complement here, but the complement clause is realized with mochi. But if the sentence, and that's the first example for a modification, is translated without a comma between matrix and complement clause, we have a wrong translation. So now let's move to the next construction. That is the combination of the matrix verb versprechen and the dürfen complement. You can see again two examples. The first one doesn't show the control shift translation. The other one does. Just skip this now. Here especially, sorry. No. So here we can see the third complement type, so the passive complement in combination with the matrix verb bitten, and the first one does not show a correct translation, and the translation is a bit funny in my opinion. The next one is again not correct translated, and it's also incorrect on a referential level, since although pro refers to the subject of the matrix clause here, the object of the action verb in the complement clause is identical to the object of the matrix clause, which would be in this case incompatible with the matrix verb samolity. So it's a wrong translation. And here we have two examples for the last construction, so matrix verb versprechen and passive complement. And we have the first example is correct translated, the second one is not. No, the other way around. First one is not not translated correctly, the second one is. Okay. So next slide, we see a list of modifications that are applied to the original examples. So the reason for this was, as I already said, that these constructions occurred with a more high or less high frequency in the corpus results. And I already had certain assumptions about how they may influence the translation. So first with the punctuation, so namely the comma, between matrix and complement clause. We have already seen an example for this where the sentence was translated incorrectly without this comma. So the assumption here was that the comma divides the sentence divides it more clearly into two syntactic units. So it's better understandable for the translation program, maybe. The next one is indefinite pronouns. We will see an example on the next slides. The third modification concerns the realization of the subject or object. So if we have a matrix clause without an object or a subject, and again, this assumption was that maybe the program translates these constructions more often correctly, because the program for Pro only has one constituent to choose from, and that does not invent another one, so it does not invent an object or a subject. And the last modifications are passive matrix clause and additional reference in the complement clause. Okay, I will now also give a few examples of these modifications. So I have the original sentence in brackets here, and above the modified sentence. And in the first one, you can see that while the original sentence was not translated correctly, the modified version is. The translation of the second modified sentence, where I eliminated one of the arguments in the matrix sentence, is also interesting for another reason. So first, it is interesting that the translation of the modified sentence has a dark complement. And this was not present in the original form, in the original translation. But the constituents and the assignment of control must be considered here in more detail. In the German sentence, we have a subject, first person plural, in dem wir darum baten, which refers clearly to Bruder Jason und mir. In the German, and it must be also assumed that pro in the German complement clause refers to this. But in the translation, we have the first person singular of immerse. So obviously, the control shift is kind of realized, but only one of the two subject constituents is included. There's a next example. I will skip it here. We have another example for the passive matrix clause, which again shows a correct translation in the of the modified sentence. And here an example for the last modification, the reference in the complement clause, where I added a possessive pronoun in the complement clause. But we can see here that in both cases, there's no correct translation as far as the control is concerned.
Michel, can you please come to the end?
Yes, sorry. Okay, I come to the statistical or quantitative part. And as I've already said, that the word statistical must be used cautiously here, because in some cases the data does not allow any real statistical analysis. I have partially tried some chi-square tests, but however, these were not very meaningful, because sometimes the data was too small or too different, or the frequency was too different. But we can see here at the table for the original sentences that the overall the incorrect and correct translations are relatively evenly balanced. But this means a very high error rate. So we have 84 out of 152 sentences were not translated correctly. And if you assume that machine translation is very reliable nowadays, this is a high error rate. So I will skip this one, and only one word for this. So if you look at the modification, realization object, realization subject, we can see that all but only one sentence is translated correctly. Here we have a table with the deviations. This figure can again be interpreted in such a way. So here we can see how often a respective modification had a positive or negative effect on the translation. So only in the case of the realization of the subject or the object, we can say that there's a clearly positive influence. For the others, we don't only have tendencies. Okay, and here we have the structures of the translations of the original sentence for the complement type 1 dürfen and the matrix verb bitten. And so we have in German the model property of permission with zu dürfen. In Croatian, this complement clause is realized in 3 different ways. So we have the simple dark complement, we have a dark complement plus dopustity, and a dark complement and no dark complement but mochi. And the majority of those translations that have realized the German complement clause with a dark complement, with a simple dark complement, and do not transfer this model property of permission, do not show a correct control shift. But the other ones that realize this with dopustity or mochi do. They have a significantly lower frequency, but are more or less consistently correct. So, okay. Then I come to my conclusion. So first we can say that these special constructions indeed pose a challenge for machine translation. We have a general balance between correct and incorrect translations and original examples, but this also means a high error rate. No real quantitative conclusions can be drawn from the punctuation due to the few deviations. When modifying with indefinite pronouns, we have both strong positive and negative effects, at least for complement type 1, but it depends on the matrix verb which one. If we eliminate one of the constituents in a matrix sentence, so subject or object, this leads to almost exclusively correct translations. And in the constructions with a passive matrix sentence, there are again only few deviations, but it again seems to depend on the matrix verb whether there is a positive or negative effect. What is important to note is that it's not really possible to answer why the modifications or the different sentence structures influence the translation in the way they do. So we simply don't have enough insight into the program's processes. At least I don't have. So we can only make assumptions about how how Google Translate deals with these structures. So as has already been done with the punctuation, for example, or the realization of the subject and object. Okay. And further investigations, creation is a target language does not seem to be an isolated case. This also applies to the translation program. So if we translate some of these constructions with DeepL into Russian or use ChatGPT, we also have problems. So maybe control shift constructions are like kind of a universal difficulty for machine translation systems. And yes, the data I had is unfortunately a bit limited, but so the inclusion of additional translation systems, other languages, other control constructions, And of course, a larger database would provide an interesting basis for further investigations. Okay, now that's it from my side. Sorry.
Thank you. Thank you very much for these detailed insights into your current work. As I understood, this is also your PhD topic. So now I'm opening the floor for comments and discussion questions, please.